blue, and we'll do skinny.
Catherine found out yesterday. Like about how you guys
Change of variables and indefinite integrals is a big fancy name for something that we're just going to call UDU, which will make sense in a little bit. This will allow us to solve integrals which we haven't been able to solve so far because we know that there's no product rule, no quotient rule, no chain rule. And so the problems that we've seen so far that would involve chain rule, product rule, and quotient rule, we've been able to algebraically manipulate to simplify them so that we can solve them using the plain old techniques. However, what if we have something like this? This will be example numero uno. Square root of 8x plus 5 dx. So we're back to indefinite integrals where we're going to get a function as an answer, not a numerical value. So fn int's not going to help you here. We got to crank this out. Notice I can't algebraically manipulate that. I could write it as 8x plus 5 to the 1/2, but that's not going to do anything for me, and it appears that it's a chain rule, which, again, chain rule doesn't work. So we're going to use this technique called UDU, which is a simple substitution technique. The trick here, and the thing that's going to frustrate you, is figuring out what to pick for u. And this is why you do your work in pencil, because on a couple of these, you're going to pick the wrong u. And so one of the things is that we're going to do today is not only do I want to show you how this process works, but I also want to show you how you can tell when it's not working. Okay? So you have a couple options for u here. I could pick x to be u, which would be really silly, because that would just be 8u plus 5, square root of 8u plus 5, which doesn't change anything. You could choose 8x to be u, you could choose 8x plus 5 to be u, or you could choose the square root of 8x plus 5 to be u, which again would also be silly. So in the first one, I will tell you that I'm going to choose 8x plus 5 to be equal to u. I'm guessing?
How are we supposed to just guess?
Initially, yes, but as you do more of them, you'll get more comfortable recognizing what your u term is. Before I substitute, though, I got to do a little bit of work over here. I got to take the derivative of this. So the derivative of u is equal to, help me out, 8 dx. So we're doing this implicitly. I've got two variables there. The derivative of u is du. The derivative of 8x plus 5 is 8 dx. Last step, solve for dx. And there's a reason why I'm doing this. You'll see in a second. Okay, so what's u equal?
8x plus 5.
And what's dx equal? Good. Now we do a substitution. So come back to the original problem. I'm going to get rid of this and turn that into a u. And what's dx equal to? It's right there. 1/8 du. So cleaning that up, I get 1/8 out in front, and I get u to the 1/2 du. And we should all be able to take the antiderivative of that, can we not? Good. What is it, Steph?
To 3/2 u to 2/3, or wrong. So 2/3 u to 3/2.
Grant, help her out.
Plus u.
Plus
Indefinite integral. So that cancels there. So 1/12. Now I have to substitute back in for u. 8x plus 5 raised to the 3/2 power plus c. And there's my final answer.
You don't have to multiply.
No. No. Yes, Meg.
Why'd you work the du? I thought if there was a variable you add like if that was 5, you would add an x to it when we're taking it.
I don't know if I follow your question.
So what?
1/8
So du just like not something?
du is the same thing as dx. When you take the integral, it goes away. It's just there to tell you what the variable is. So in the initial problem, the variable is x. After we do the substitution, the variable becomes u.
Okay.
Once you take the antiderivative, it just goes away.
Okay.
I'm done telling you what the variable is now. Move on.
Okay.
Okay? Seems easy?
Yeah, it's gonna get harder.
Oh, it's gonna be fun. You're gonna love this. Numero dos. Let's get crazy and change the color.
So we're gonna hate this.
You're not gonna hate this.
Yeah, I said that yesterday.
We're gonna hate this?
You're not going to hate this.
What you said we're gonna
But if I do, can I hold you to that?
Yes, you
Are
can.
you lying to me?
Yep.
Maybe turn that in for extra credit.
Just remember, I never lie.
But that's a lie.
It's always Grass's fault.
That's right. I can't read my own notes. That's a 9. Okay, so we're gonna ramp it up just a little bit. Okay, maybe a lot of it. What do you want u to be?
8x to the 5th minus 7.
8x to the 5th minus 7? What about the 8? What about the x to the 4th? What about the 9?
Just erase those.
Let's go with what you suggested, though. We'll try it, and then we'll see what happens.
Skip 'em.
You want to use. What's that?
The shoe.
A whimpering dog. Because it.
Who's realized how horrible u to u is going to be, so it's just cowering in fear. Okay, watch how cool this is. What's a derivative of the right side?
40x to the 4th.
Wait.
dx, thank you.
Down to the no, when it's wrong, you know, you get the.
Yeah, then you know what mistakes to make. You're assuming that this is wrong? You have no faith in Grant's abilities?
You said,
I don't either,
okay,
it's
I guess
fine.
we'll try
Yeah,
that
so
at
I
the
don't know.
beginning.
Are we supposed to?
Right. So we're trying it. What's wrong with that? Solve for dx. dx is equal to 1 over 40x to the 4th du.
I don't even know what I messed
And
up.
now we have u, we have dx, so now we can substitute.
I hate this.
So this becomes u to the 9th, x to the 4th, 1 over 40x to the 4th du.
I don't see anything
Now,
like that.
one of the first things that you're going to notice is that if you get done with your substitution and after you simplified, if you have u's and x's, you made a mistake. Will we have u's and x's here?
No.
No.
Yeah.
Whoopsh, whoopsh.
Nice going, Grant.
Thanks, Emma.
1/40th times u to the the integral of u to the 9th du. We are happy. Okay, Grant, you started this mess. Finish it. What's the antiderivative of u to the 9th?
1/10 u to the 10th plus c.
1/10 u to the 10th plus c, which would then be 1/400th. 1/400th.
What just happened?
8x to the 5th minus 7 raised to the 10th power. Plus c. Now, there's no reason why you couldn't start that problem by just multiplying it out,
Wait.
Multiply that one out.
right?
We'll find what?
Yeah.
It's a 9.
8x to the 5th minus 7 to the 9th power. You can just multiply it out, right? And then multiply everything by x to the 4th. I mean, it wouldn't be that big. Okay, it would be hellacious. So this allows us to avoid that. How are we doing so far?
Wait.
Because the next one, I want to do this problem again, but do it wrongly.
Incorrectly.
Probably bad English there, right?
So is it usually
It's like
one?
non-
this
well.
morning, so it's-
Non-welly.
Mr. Reed,
Yes?
is the U usually what's in the parentheses?
Usually, yes.
Yesterday was the best day of
Yeah,
my
you can't
life.
say it.
So let's suppose Grant didn't bring his A game and he chose x to the 4th to be u.
Oh, silly Grant.
So du would be equal to, help please? Not plus c, derivatives.
dx.
That's what's gonna happen too. You're gonna put plus c's on derivatives and you're gonna do a prime on an integral.
d of c. d of plus c.
Now you're just rambling.
No.
Do the substitution. We get the integral of 8x to the 5th minus 7 raised to the 9th power. This becomes u. And du is 1 over 4x cubed du. Not good. No canceling going on. I have x's and u's. This is bad. We made a boo-boo. Then you erase and try it again. And as the problems get more complicated, your options for u will grow, but your expertise in the field of choosing u's
Oh my god.
will get better.
That like makes me.
What happens if you would have included the 9? What if,
You would have had to take the derivative using chain rule, and you would have seen that things didn't cancel. That's a good question. Number 3.
so it's going to be constant.
Let's just use the.
Wipe around the what does that mean?
Carolyn, what do you want to choose for you? The worst that can happen is you're wrong.
The entire thing is.
You're making use of your American right to abstain?
Yeah.
Okay, good. I'm overruling. It's not a democracy. It's a dictatorship.
What is it?
What do you want you to be?
It's worked that way.
Popcorn chick.
Popcorn chick.
Yep, there is.
Do I look like Regis Philbin?
You don't not look like him.
I don't not look like him. Shall we review your options for you? You could choose x. That would be dumb. You could choose 5x to the 4th plus 6x. You could choose x to the 5th plus 3x squared plus 5. You could choose x to the 5th plus 3x squared plus 5 all raised to the 3rd power. Or you could take the whole shoot match, which would be 5x to the 4th plus 6x all over that business. That would also be dumb. I would not go with options 1, 2, or last one.
So third.
So one of the other possibilities. You want to go with the whole bottom or just the inside part inside the parentheses?
Just the inside.
Stuff inside the parentheses, based off of Olivia's earlier comment.
I don't even know what she said.
Oh, good.
Usually in the I'm in Jordan.
It looks like a
What's DU, Carolyn?
5x,
Shh.
6x, and then dx.
Well done. So dx is equal to 1 over.
Oh, it shows the same thing.
Did she choose wisely?
Yeah.
Yes, she did. So now we do this. Well done. Wasn't so bad, was it?
I mean, it was gas.
You survived it. Things could be worse, right? 5x to the 4th plus 6x over u cubed times 1 over 5x to the 4th plus 6x du. Whoopsh, whoopsh. The integral of u to the negative 3 du. Now, I will say the nice thing about du or u problems is that once you do the substitution correctly, the antiderivative is pretty easy.
Wait, Mr. Reed, did you never do that stuff that makes this
Oh, I never use never. Yeah.
So, you plugged in u and then you figured down the bottom and then where did the 1 multiplying by 1 over 5x and 4 plus 6x?
Where did this go?
Wait, why did you put that there?
Because that's what du is equal to.
So you,
So I substituted in for dx. I turned dx into that business right here.
okay.
Now, as you get better at this, most of you will be adept enough that you can skip this step. And you'll be able to go right to here. But I think that might be a little ways off. All right, Carolyn, let's finish this. What's the antiderivative of u to the negative 3? Don't look at me in that tone of voice.
Don't look at me in that tone.
Not
Negative.
What?
U to the negative
For antiderivatives, you add or subtract from the exponent. So what's negative 3 plus 1?
Let's see.
Oh, dang it.
And of course, we wouldn't like the negative exponent, so we'd get rid of that. So we'd get negative 1 over 2 times the quantity x to the 5th plus 3x squared plus 5 squared plus c.
Plus being on the bottom.
Doesn't
You
matter.
explained that step again. Not
Which
that,
step?
The one where you cancel the number stuff.
This step,
Yeah.
I substituted in. She told me she wanted this to be u, so I turned that into a u. That's u cubed. This stayed there because I didn't have a substitution for it. This I got from solving for dx over here, so this is dx. And then conveniently enough, since she chose wisely, these two canceled. When this canceled, I got this, and everything's in terms of u, so I'm happy.
Is the DU something different?
The du, here. The du goes with this guy. This is that.
Okay.
You can't have your answer in terms of u. Like you can't just have negative 1 half u.
No, you gotta substitute it back in at the end. Yeah. For the most part, we will see some instances where you can leave it in u because you're gonna do more with it, but initially what we're doing now, you just
Okay.
put it back in terms of x. Where would life be without some trig?
No socks would be-
Oh my.
No.
If you cut that, that's what life would be.
Quit your whining.
And for Tommy, do you know that Tommy made that shirt, not knowing it was supposed to be different colors?
I'm telling you.
It's a condition. That is necessary. You'll be okay.
Is it? No, I thought I saw something.
Couple things to review trig stuff. This statement makes no sense. You have to take the sign of something.
Why?
I'm gonna preface this so just so you don't freak out, Rosie. I'm not making fun of you. But you cannot divide by sign. Okay, it doesn't, if I have the sign of x equals 2, I can't just divide by sign. Okay, those don't cancel. All right, again, I'm not trying to be funny, I'm just trying to be preemptive to make sure you don't make these kind of mistakes.
It looks good. It just looks good.
What are my options for you? Peter?
Sine, or, sine of the fourth, 8x,
Could take the sine of the fourth 8x.
could be cosine 8x,
Could be cosine 8x.
or the whole thing,
Could be the whole thing.
or 8x.
8x. Beautiful. Or just x, which again, dumb. Okay. What do you want to try?
Sine of the fourth, 8x.
All right. I like it.
I don't like it.
I thought you said slime had to be the sign of sugar.
It is.
I'm sorry, what?
Wouldn't you? It looks like that. Is that? Okay. I just.
Are you gonna ask a question
I
or?
did, but I got attacked for it. So
I haven't attacked you, I just asked for what you said, that's all.
Answer your question.
I thought the sign of the fourth and the 8x weren't together.
Why would you say that?
They are.
Now I know.
Beautiful. Peter, what's the derivative of sine to the fourth 8x?
4 cosine,
No, not yet.
4 sine to the third 8x times, cosine, cosine of the fourth, cosine 8x,
But
plus, no, c, dx.
Time.
Oh, times 8
what just happened?
dx.
I know.
Shane.
Thanks,
How we feeling about that choice for you there, Peter?
I don't like it.
Don't like it?
Not really.
Why?
It's really long.
Too much work?
Science and
Too
cosine.
much.
All right, well, let's, if we solve for dx then, dx is gonna be, we got a du there, and then this whole thing is in the denominator. So 8 times 4 is 32, sine to the third 8x, cosine 8x. Okay, come back over here. He chose this to be u, so that's u. And then this, I don't have any sub for that, so that's just gonna go, whoops.
32.
That's just going to be there we go, cosine 8x. And then dx is this whole messy business over here. So 32 sine cubed 8x times cosine 8x du. Is that weird? Oh, all right. So then cross out the cosine 8x's. Or cosine of 8x's. And we are left with the integral of u over 32 sine cubed 8x du. How'd you do, Peter?
Not good.
Not good. Why?
There's U's and X's.
There's u's and x's, correct. We've canceled everything that we could. There's u's and x's, so that means he chose poorly.
How do you know?
Because there's u's and x's.
I mean, how do you know at the beginning?
You don't.
You.
Well, I do.
Educate
Yeah, I do.
us.
But I let him go with that because I want you to see what happens when we make a boo-boo. Would you like to revise your initial choice?
Yes.
Okay, hold on. Let me do some erasing.
Wouldn't it suck if you like did it every single like
Every single opportunity in your last one.
yeah. And then the answer would be like 1 and you'd be like, okay.
Punch somebody.
Next choice. Just 8x. All right, let's try it. Whoop.
You like that one?
8x.
You're writing in pens, so you're feeling pretty good.
All right, du is equal to what? Shh. 8 dx. So that gives me 1/8 du is equal to dx. Okay, that's a little simpler than the last one for sure. So doing a substitution over here, I get the integral of the sine to the 4th u times the cosine of u times 1/8 du. It looks prettier. I don't have u's and x's. That's a good sign. It's a good sign.
Oh God, I'm leaving this class.
Okay. What's the integral of sine to the 4th u cosine u, Peter?
So negative cosine x or cosine to the 4th u. Wait. What was the question?
What's the integral of that thing?
It's not that negative. It's not negative cosine 4th.
Got a little problem here, right?
Yeah.
We got a product rule with a chain rule.
Yeah.
So what can you conclude from that?
And
Bad u.
Oh.
I told you. You should never
Okay,
put it down.
Peter, I'm feeling good about this, buddy. 3rd time's a charm.
The whole thing, Peter.
Don't do it.
The entire thing, yeah.
Here we go.
Oh.
Here we
This is gonna be
here we go.
so much of
What do you got, Peter?
Yeah. I thought we were gonna do it at lunch.
Do all of it.
yeah, all of it, I guess.
All of it is seldomly, if ever, a good choice.
DX.
Cosine it.
Let's try it. Let's go.
No,
Okay.
And cosine it.
not a bad choice. But I'm gonna say the agree and show you that that ain't gonna work.
Is that cosine?
I think that was sign of it, sure.
Yeah, it's sine of 8x.
Pat, where are you?
I wouldn't.
You just don't bring the.
You can change the problem.
No, it's just, then it'd be u to the fourth.
What's du? Okay, so here you get it dealing with derivative of sine versus integral of sine.
Cosine.
Yeah, cosine. Keep going. 8x times 8 times dx. So dx is equal to 1 over cosine 8x. Oh, there's an 8 there too. 8 du. Before we even jump into the substitution, just to save ourselves a little bit of hassle and me not having to erase again, did he choose wisely?
Yeah.
Yes.
Totally.
So we're going to skip that substitution step now for those of you that are advanced. If I take this and substitute it over here, I should get 1/8 u to the 4th du.
What? Oh, okay.
The cosine 8x cancels with the cosine 8x. The 1/8 moves out in front. And then sine of 8x is u, so that's u to the 4th. Which, you know, is 1/8 times 1/5 x to the 5th. No, u to the 5th. Come on, Reedy. Plus c, which is 1/40th sine to the 5th 8x plus c. Okay. So it will become a trial and error. One thing I want you to notice is that one of the poor choices that Peter made when he got to the substitution, he didn't have x's and u's. We eliminated that problem, but there was another problem there in that we still had a product rule and a chain rule, which doesn't ever work in integrals. So you got to be able to recognize what's going to cause problems. The sooner you recognize that, the easier off things will be. Let's do one more quick example. This one's easy.
Are we ever gonna have a product
Are we ever going to have what?
rule?
There is no product rule for integrals.
Didn't we do a chain rule?
We turned a chain rule into something that we can work with, but there's no chain rule when to work directly with integrals. Not many choices for you. Tim, what do you like for you? Let's talk about our possibilities first, then we'll talk about what you want to try.
12x.
12x is one possibility. Well, let's talk about the dumb ones first. What would be dumb choices?
X.
Good, and
Sine 12x.
good. Got the dumb ones out of the way. We won't even talk about them anymore.
12x.
Is there any other possibilities?
No.
If we eliminate the dumb ones, it pretty much tells us what we need to do, right?
Right.
Okay. And from there, it's pretty easy. So not a lot of options. The reason I wanted to do this example is that so you can realize when you're supposed to use a UDU. Why do I need to use a UDU here? Other than the fact that we're talking about UDUs and I just said let's do another example. Because that ain't going to happen on the quiz. It's not going to say use a UDU to solve this problem. Let me ask my question again. What indicates that you need to do a UDU for the initial problem? What's going on there? Okay.
Is it 'cause it's 12x and not just x?
Right, so we have a chain rule. Anytime you have a chain rule, product rule, or quotient rule that can't be algebraically manipulated, you've got to use a UDU. And we've seen some product rule and chain rules that can be solved without doing this, like we had the one x squared plus x over, I forget what it was, let's say x. Okay. you can split that into the integral of x plus 1 dx and solve that. But if it can't be algebraically manipulated, then you have to go to a UDU. Okay. A couple other things, and these are simply time savers. What can you tell me about an even function? Something. Can you give me an example of an even function? X squared is an even function. So if I draw a picture of x squared, what can you tell me about that graph? It's symmetric about the y-axis. So if you need to find the antiderivative of an even function from, let's say, negative a to a, and this is just a time-saving device, instead of going from negative a to a, I could just find half of it and then double it. So that's the same thing as doing 2 times the integral from 0 to a of f of x dx. Does that make sense? If it's the same on the left and the right, just find the area under the curve on the right and double your answer. There's a couple caveats here though. Number one, you need to know it's an even function. And number two, it has to go from negative a to a. It can't go from a over here somewhere and then some other b here. It's got to be same amount on both sides. Change colors. What can you tell me about an odd changing colors? What can you tell me about an odd function? Say again? No, that's not a function. About the origin. So an example of an odd function would be x cubed. So I'll let you figure this one out on your own. What happens if I want to take the integral from negative a to a of that odd function?
0.
It's 0. Trust me, you're going to want to remember this, because you're going to get some nasty odd function. You're going to grind out all the work. You're going to plug in negative a and a, subtract the 2, and then you're going to get 0, and then you're going to swear. If you just realize that if I go from a to negative a, this area matches this area, except that one's positive and that one's negative. Great.
What if it was shifted left or right?
Doesn't work. Because then it wouldn't be an odd function anymore. And how do you determine if a function is even or odd? What's the easiest way? Powers, right. If all the powers are even, it's an even function. If all the powers are odd, it's odd. Remember that x is odd, and a constant is even, because a constant like 5 is 5x to the 0 pregunta.
Wait, so if you shift it left and right, why doesn't it work? Because it's just moving.
Yeah, that's what I'm thinking.
Because you're not going from, you're not, if I shift this left or right and I take these values with it,
Yeah.
I'm no longer going from negative a to a. If I shift it left and right and I go from negative a to a, then I'm not going to get a symmetric area. You understand what I'm saying?
Oh, okay.
Your answer is yes. If I take this whole thing with these and shift them over, if I'm going from negative 4 to 4, and I shift it over and go from negative 6 to 2, we're fine. But if you just shift it and keep the same limits of integration,
So
it's
as
not
long
going
as
to
the
be symmetric.
limits shift.
Right, which seldomly, if ever, happens. Really? Oh. All right, we're almost out of time. Make sure I covered everything. We're good to go. So we didn't have time to go over the last day of 4-4, so we'll start tomorrow with going over 4-4, and then going over the first day of 4-5. The first day of 4-5 is a lot of computational grinding out, getting used to this, trying to pick a U. You can watch me do all these UDU problems in the world. It's not going to sink in until you get in there and get your hands dirty. You got to try picking a U, because not only do you need to learn how to do it, but you have to learn how to notice when you've made a mistake. Otherwise, you're just going to start doing it and think everything's peachy keen and get a weird answer. Okay? Questions? Awesome.
It's like a square root.